Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 6th grade topic, finding the LCM of small numbers. If you're new to my channel, I'll be putting time codes in for my video in the description box below so you can skip ahead to any sections of this video that interest you the most. We're going to be focusing on small numbers today because in my next video next week, I'll show you a more appropriate method for larger numbers. As always, if you have any questions about what you see here today or anything in your own homework, feel free to either put it in the comment box below or visit me on Facebook at Tutor Me Sempai and tell me all about it there. When you find this video helpful, remember to leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. But without further ado, let's talk a little bit more about finding the LCM of small numbers. Before we get started finding the LCM, let's talk about what the LCM means. So the LCM stands for least common multiple. And that just means we're going to find the smallest number that both or all of our numbers go into. For example, let's say you have 4 and 6. 4 and 6, we want to find the smallest number that both 4 and 6 go into. So in this case, it would be 12. Both 4 and 6 go into 12, and there's no number smaller than 12 that both of them will go into. So we say that 12 is the LCM. So there are a few different ways that you can find the LCM. Let's look at our first method. Our first method we're going to talk about is something I call the fishing method. Now, the fishing method had nothing to do with fish, but the concept behind fishing, which is patience. Fishing takes a lot of patience, and depending on how big your numbers are for this method could take a lot of patience. So we're going to focus on small numbers so you can see where this method really shines. Another reason why I refer to this as a fishing method is this is a trial and error type of method. Just like fishing, you don't know if you're going to catch a fish on your first try, your second try, or your third try. You're just going to keep casting your line out and hopefully you can catch a fish. We're going to be doing the same thing. We're going to keep throwing numbers here and see which one works. So it's a trial and error type of method, just like fishing would be. So the first thing you want to do is you want to list out your numbers here that you're trying to find the least common multiple of. And then we're going to write out 1 to whatever our largest number is, in this case, 6. 1, 2, 3, 4, 5, 6. After you wrote out all your numbers here, we're going to multiply all of these numbers by both of these numbers. So you get 4, 8, 12, 16, 20, 24. And for this one, you get 6, 12, 18, 24, 30, and 36. So now we have all of our numbers here. We try to see which ones do they have in common. So you see there's a 24 in common, right? So I'm going to underline these. There's a 24 in common. And do we have anything else in common? Yes, we have this 12 here. Anything else in common? No, nothing else is common between these numbers that we wrote here. So we want to find the least common multiple, right? The LCM. Is 24 the least common multiple? No. It's a multiple, right? And it's in common, but it's not the least common multiple because we see that we can go down to 12. So this is what I mean by the fishing method. We don't know where we're going to stop. You can go pretty far depending on how your numbers work out, or you can end really soon. When you have smaller numbers, you're likely to end it sooner rather than later. So in this case, you have an LCM of 12. So let's see what happens when we throw slightly bigger numbers into our fishing method. Because I ran out of space, I broke into 2 parts, but we're going to go from 1 all the way up to 18 for both of these numbers. Now the reason why we stop at the biggest number is because whenever you do the smallest number times the biggest number, those are always going to be common factors. However, to find the LCM, we have to find the least common multiple. So yes, although it is a common multiple, we don't know off bat if it's going to be the smallest one. So we stop there because we don't have to go any further than that, but it could happen anywhere between 1 and 18 for this example. So let's fill out this table and see what we get. So we filled out our table for 16 and 18 going from 1 to 18. And you notice for 16, if we go to 18 here, we got 288. And for 16 going with 18, we have 288. So you see we have a common factor because we went all the way to these ends. However, that doesn't mean it's the smallest one. Do we have anything else that's in common that's smaller than 288? Well, we have this 144 here, right? 144 is also in common. Anything else smaller than 144? There's nothing else smaller than 144. So we don't have to go all the way up to 288. We could have stopped early if we saw that. But because, just like fishing, you don't know when you're going to have to stop, you're just throwing your line out there. We're just going to keep throwing numbers until we stumble upon the right one. Trial and error. This is the fishing method. So if you happen to stop early, please don't go any further than what you already found. But if you haven't found it yet, just keep trying and eventually it'll show up. So you see how that previous method, our fishing method, could take a little bit more patience because you don't know where you're going and you might have to go pretty far to find your answer. It might take a little bit longer to get where you need to go. However, we have another method that will make things a lot quicker, and we call it the tree method. Now, this might look familiar if you saw my video on greatest common factor. They both use the tree method, in which you're really just using the prime factorization. The tree method helps you take advantage of the prime factorizations of your numbers. So let's break this out into its prime factorizations. We're going to start with 16 and 18 again because we already found the least common multiple to be 144. So we want to test to make sure our tree method gives us the same thing we found with our fishing method. Starting with 16, what are the factors of 16? Well, you have 8 and 2. Can you break down 2? No, but you can break down this 8. What is 8? We have 4 and 2. Can you break down this 2? No. So let's break down this 4. What is 4? That's 2 and 2. So we broke this out into all of its factors that are prime. We can't break this out anymore. Let's do the same thing for 18. What is 18? Well, that's 9 and 2. And you can't break down to 2, so let's break down to 9. What is 9? Well, that's 3 and 3. Can you break down any of these 3s? No. So you see we have our prime factorizations using this tree method. The tree method just breaks this down into each of its factors one at a time. You don't have to choose the ones that I chose here, but this helps me just kind of keep things moving along. Now we're going to take these factorizations and rewrite them so we can move on to our next part of this method. Once you have the prime factorizations written out, now we move on to pairing things. So which factors do they have in common? Well, this 2 here. This 2 pairs it with something in the bottom. So we circle those because we're going to keep the pairs together. The pairs are going to act as one. It is important that you pair them up as best you can. Are there any 3s in the top? No, so none of these have any pairs, and there are no more 2s in the bottom to pair with these 2s. So this is the only pair you have for these numbers. And this is where we're going to diverge a little bit from what we did when we were trying to find the greatest common factor using the tree method. We're going to take all of our factors and multiply all of them together. However, any pair acts as one factor. So we're not going to write this out twice. Every pair acts as one factor. So we're going to take all of these, and I'm going to cross them out so you know that we've used them. So we're going to take this 2, this pair of 2s, and write it once, this 2, this 3, this 3, and we're going to multiply all of these together. And that answer is going to be our LCM. So what is 2 times 2 times 2 times 2 times 3 times 3? Well, this is going to be 144. Does it look familiar? Yes. 144 is exactly what we got using our fishing method. But you see here, it took a lot less time. By just breaking it out into its prime factorization, we can make use of that and find our LCM a lot quicker. So this is going to be a little bit more suitable for slightly bigger numbers where our fishing method will tend to be worse. So I hope you're following today's examples. Now remember, your fishing method is going to be pretty good when you have really small numbers. You might not even have to go that far. However, when you start getting into those larger numbers, the fishing method tends to do a little bit worse. Now you have your tree method, which will be a little bit better. However, that also has its drawbacks. So make sure you come back next week and I'll show you how to handle those really big numbers with another way of finding the least common multiple. If you have any question about what you saw here today, remember to put them in the comment box below. Or you can visit me on Facebook at Tutor Me Sempai and tell me all about it there. Especially any question about your own homework. If you haven't done so already, remember to leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this is another session of Tutor Me Sempai.